Okay, so the problem we have here is we are assuming that n is a positive integer and 2 to the n plus, or 2n plus 1 is prime, and we are trying to show that 2n plus 1 divides either the nth Mersenne number or the nth Mersenne number plus 2. We can just note, because this notation from my understanding is not very common, we can note mn equals 2n minus 1, and then this implies that mn plus 2 equals 2n plus 1. So we want to show 2n plus 1 divides 2 to the n minus 1, or 2n plus 1 divides 2 to the n plus 1. Now, we know that the greatest common divisor of 2 and 2n plus 1 is going to equal 1. Therefore, we can refer to Fermat's little theorem, which I will just paste in a second. No S. So I have pasted Wikipedia's definition of Fermat's little theorem here. And at the bottom, we see that if A is not divisible by P, or A is co-prime to P, then Fermat's little theorem is equivalent to the statement that A to the P minus 1 is an integer multiple of P, or that A to the P minus 1 is congruent to 1 modulo P. So these are co-prime, 2 and 2 to the n plus 1. So we know that using Fermat's little theorem, 2, right here, to the power of 2 to the n plus 1 minus 1. Recall that this is a prime number by the original assumption in our question. We know that this is equal to 1 mod 2 to n plus 1. Therefore, we can just remove these, and we know that 2 to the power of 2n is congruent to 1 mod 2n plus 1. An equivalent statement here is that 2 to the power of 2n minus 1, because we're moving this to the other side, must be congruent to 0 mod 2n plus 1, which means 2n plus 1 must divide 2 to the 2n minus 1. We can expand 2 to the 2n minus 1. We can note that it equals 2n minus 1 times 2n plus 1, which is congruent to 0 mod 2n plus 1, which implies that 2n plus 1 divides this product here, 2n minus 1, 2n plus 1. Now recall how we defined our Mersenne number, that this is mn plus 2 and this is 2n minus 1. So because we know that because 2n plus 1 is prime and 2n plus 1 divides this product here, 2 to the n minus 1 times 2 to the n plus 1, we know that 2n plus 1 divides 2n minus 1, or 2n plus 1 divides 2 to the n plus 1. And we are done.